All right, let's dive into something that's absolutely critical for anyone working in the cloud-native world, making Spring Boot and Kubernetes work together perfectly. And I'm not just talking about getting your app to run. We're going to talk about how to build applications that are truly, genuinely resilient.
So, here's how we're going to break it down. We'll kick things off with the big picture challenge, the why behind all this. Then we'll get into the weeds of Kubernetes' 3 essential probes and how Spring Boot's actuator module is the perfect dance partner for them. After that, we'll connect the two, step by step, and finish up with some pro tips for making this stuff rock solid in production.
Okay, first things first, the Cloud Native Challenge. This is where we learn the hard lesson that just because your application's process is running, it doesn't mean everything's okay. I mean, really think about that question. Kubernetes is amazing at what it does, but it does have a bit of a blind spot. It can see that your app's process is up and running, but it has no clue what's happening inside. Is your app stuck in an infinite loop? Has it lost its database connection and is just spinning its wheels? Kubernetes can't tell. From its perspective, the lights are on, but nobody's home. And that blind spot is what leads to this, the dreaded crash loop back-off. We've all seen it. This is super common with Java apps, right? The JVM takes a little while to warm up. So if Kubernetes checks on it too early and says, hey, are you healthy? And the app isn't ready to answer, Kubernetes thinks it's broken and kills it. This kicks off a vicious restart cycle, and your app never actually gets a chance to start. So how do we fix this? Well, Kubernetes has a solution built right in. Think of them as a team of on-call doctors for your application. It's 3 essential probes. So what are these probes? Well, they're basically just little checkups that the kubelet, that's the agent on every Kubernetes node, performs on your container. It's constantly asking questions like, are you okay to start? Are you still alive? And are you ready for traffic? And based on the answers it gets, it can make really smart automated decisions to keep your system healthy. And it's so important to understand that these 3 probes have very different jobs. First up, the startup probe. Its whole purpose is to give slow-starting applications like a Java app a grace period. It tells the other probes to just chill out until the app is fully initialized. Then you have the liveness probe. This one is looking for catastrophic failure. If it fails, it means the app is basically a zombie, and the only fix is to restart the container. And finally, the readiness probe. This is your traffic controller. If it fails, Kubernetes just stops sending it new requests for a while. They're not interchangeable, they're a team. All right, so that's how Kubernetes asks the questions. Now let's look at the other side of the conversation. How does our Spring Boot application give intelligent answers? Well, it all comes down to the actuator module, which is basically our application's internal voice. See, since Spring Boot 2.3, the whole idea of health got a major upgrade. It's not just a simple up or down anymore. The framework introduced what it calls availability states, which gives our app a much more nuanced understanding of its own health. And wouldn't you know it, it tracks 2 separate states, liveness and readiness. Sound familiar? And the distinction here is absolutely key. Think of it this way. Liveness state is about a fatal condition. If the state is broken, the app is basically saying, something is fundamentally wrong with me and I can't recover. Please just put me out of my misery and restart me. But readiness state is different. Refusing traffic just means, hey, I'm okay. I'm just busy for a second, maybe warming up a cache or something. Just don't send me any new work right now. And here's the absolute magic of it all. Spring Boot is smart. When it's packaged up in a container and running on Kubernetes, it detects that environment and automatically exposes these liveness and readiness states at 2 dedicated endpoints. You don't have to write any complex code for this. It's just built-in cloud-native intelligence. Okay, enough of the theory. It's time to actually forge the connection and see how this all comes together in practice. Let's walk through it step by step. On the application side, this could not be easier. Step 1. You add a single dependency to your project, the Spring Boot Starter Actuator. That's really the main thing. Like we said, inside Kubernetes, Spring Boot will automatically enable the probes. If you want to test this out on your local machine, you just add that one little property to your application.properties file. It's that simple. So, our app is now ready to talk the talk. Let's switch hats and configure our Kubernetes YAML to tell it how to listen. This is where we wire everything up in our deployment manifest. First up, and I cannot stress this enough for any Java application, the startup probe. Just look at the settings here. We're telling Kubernetes to check every 10 seconds, but to allow for 30 failures before it gives up. 10 times 30? That gives our app a 300-second or 5-minute grace period to get itself together.
This is the single most important thing to prevent that dreaded restart loop we talked about earlier.
Now, once that startup probe passes, the liveness probe takes over. It's pointing to the very same endpoint, but its job now is to be the long-term health monitor. Every 10 seconds, it's going to ping the app and ask, "You still good?" If it ever gets a bad response, Kubernetes knows the app has entered a zombie state, and a restart is the only cure. And finally, we have our traffic cop, the readiness probe. This one points to the dedicated/readiness endpoint. Its job is to decide if this specific pod should be included in the load balancer. If the app is busy or waiting on something, this probe fails, and Kubernetes instantly, gracefully pulls the pod out of rotation. No dropped connections, no user impact. This is the key to zero downtime deployment. Okay, having a basic setup is great, but going from "it works" to "it's unbreakable in production" requires another level of thinking. So let's cover some pro tips and, more importantly, some really common pitfalls you need to avoid. And hey, don't just take my word for it. This is a direct quote from the official Kubernetes documentation. They are literally warning you that if you get this wrong, especially with liveness probes, you can accidentally create a system that tears itself apart. A bad probe can be worse than no probe at all. So here are the golden rules. First, always use all 3 probes for Java app. Always. Second, and this is the big one, your liveness probe must be self-contained. It should never depend on a database or another API or anything external. Why? Because if your database has a temporary outage, you don't want Kubernetes to restart your entire fleet of applications. Readiness, on the other hand, can check those things. And finally, be realistic about your timings. This table really lays it out. Your primary database? Absolutely not in the liveness check. But in readiness? Yeah, probably. If your app can't do its job without the database, then it's not ready for traffic. Same logic for a message broker. But what about some non-essential, optional API calls? No for both. Your application should be resilient enough to handle that with something like a circuit breaker, not by failing a health check. And this is a huge gotcha that bites people in production. The overload trap. Imagine your app gets a huge burst of traffic, its CPU usage spikes, and Kubernetes starts throttling it. Now it's so busy and starved for CPU that it can't even respond to the health probe within the default 1-second timeout. Kubelet thinks it's dead, restarts it, and now that newly started pod is hit with an even bigger backlog. You get a self-inflicted crash loop backoff. The fix is so simple, just give it a more generous timeout, something like 3 to 5 seconds. So we end where we began. Getting these probes right, using this powerful connection between Spring Boot and Kubernetes, is the difference between an app that is merely running and a system that is genuinely resilient, self-healing, and cloud-native. So take a look at your own applications and ask yourself, which one is it?